these days are dynamic. They're not just the static web applications where we go to read documents like Wiki and the good old Google pages. Web applications are more interactive now. We are able to log in, perform transactions, be it financial applications or even read blogs, test stories, contribute to them as well, leave comments and all of that. And your social media applications as well. You can either interact with them on the web or via a mobile phone. So it all depends. And these web applications can, or sometimes can be vulnerable. These are vulnerabilities that end users may not know about. And it's up to both the user and the application owner to ensure that the application is free of vulnerability. And on the user side, ensure that your wireless network or the network you're using to interact with this application is also secure, by using strong passwords and all of that. But my colleague will touch more on the Wi-Fi security aspect of this presentation. So which takes us to the OWASP top 10. I know almost maybe most of the people on this call must have heard about the OWASP top 10, which is the Open Web Application Security Project. It's just an open source project, a group of people coming together to rank vulnerabilities, top 10 vulnerabilities plaguing the web application out there. It's being ranked according to criticality and how often they pop up in the wild. And of all these vulnerabilities from left to right, broken access control, cryptographic failures, injections, insecure design, security misconfigurations, vulnerable and outdated components, identification and authentication flaws, software data integrity failure, security logging and monitoring flaws, and server-side request forgery. I'll just briefly touch on 3 of these, which I believe I have seen more often, during vulnerability assessments and penetration testing. The first one I'll touch on is broken access control. So this is a vulnerability that it involves a user being able to view another user's details. That's in simple terms. So what it means is, take for example a financial application. I want to view my account balance, and I'm able to view it successfully. Maybe all the application is asking me for is my account number. I input my account number, and I'm able to see this, my balance and all other details. So what happens if I replace that account number with my colleague's account number? Should I be able to see the person's details? No, I shouldn't be. There should be some level of access control preventing me from seeing another person's details. And this vulnerability is crucial because attackers can use this to, while it may not be immediately exploitable, it will give attackers a sense of more of information gathering, being able to collate information about their the victim here. So they can see the accounts, say for example, there are lots of funds in the accounts. They can, plan out ways on how to attack such individual. Another one I was speaking on is security misconfigurations. So this speaks to how the application owners handle sensitive details, like API keys, passwords, secrets, passwords to connect to a database. There was this famous breach in 2016, I think, on the Uber application. What happened was they had secrets, passwords, usernames, API keys, and all of that. They had it stored in a public repository. And somehow the attackers were able to find all of those and use that, not just finding, they used some of these API keys and all of the secrets to, steal data, extract user data, sensitive data, like user information and things like that. And those information were also published as well, like sold in the dark web. So this is quite essential because I see this a lot, and it's something that has to be managed properly. One of the ways you can manage it is making repositories private, using secret managers, and ensuring that details, even if you want to leave some hard-coded details, which I advise not, but at least ensure they are encrypted. So these are some of the ways you can curb this vulnerability. Another one I would like to speak on is the vulnerable and outdated component. Like Mr. Tony mentioned in the beginning of the class, the Lebanon attack. So what happened in the simplest way I can put it is a supply chain attack. And what is a supply chain attack? So supply chain can either be physical or digital. But in this case, it was physical, whereby the shipment of those pagers was intercepted and swapped with a vulnerable one, the one that had the bomb implanted in it, that tiny device. And because that supply chain wasn't tracked properly, there wasn't security around it, or maybe there was some form of a compromised individual in there, this was possible. But in relation to software terms, that's the digital terms, vulnerable and outdated components it's something like, we all remember the Log4j in 2021. That vulnerability is zero-day vulnerability that plagued almost all companies, because almost everyone uses Java. And that vulnerability was some companies got hacked. It was exploited because it was a zero-day vulnerability. But some of the ways you can protect yourself against vulnerable and outdated components is ensure that your application owners are getting the essential components or libraries from secured stores. Ensure that those components are licensed. Ensure that you always check them for check the versions. If the version is outdated, they should update it, because sometimes an outdated version may not be vulnerable now, but it could be vulnerable next day. So you have to ensure that these things are properly managed. And that's for vulnerable and outdated components. So I'll move on to, I don't want to touch on the other vulnerabilities, because while they are critical and essential, I'm just speaking on these three because they are the prevalent ones. And if I were to rank this vulnerability from top to bottom, like top 10, I would rank my security misconfigurations higher, maybe around number 2, and vulnerable and outdated components around number 3. And of course, these I'm not ranking it according to criticality. I'm ranking it according to how often we see these vulnerabilities. And of course, this list here is from 2021, so it gets updated with time. So I'm sure we'll see a new one anytime soon, maybe 2024 or 2025. It takes me to the second slide. I'll just quickly touch on this. Cross-site scripting. So this is a vulnerability. If you saw that list, number 3, this is under number 3, because they group lots of vulnerabilities under those categories, but this falls under injection. And it's a very, very critical vulnerability, because if a web application is vulnerable to cross-site scripting, trust me, I don't even need to sniff your traffic. I don't even need to get into your network. I can exploit this remotely, because it's something that it can be used to steal user data. For example, I can steal a user cookie and replace my own user session with that user cookie. A cookie is just a string of data or words or characters used to handle user session until the user logs out. So all I need to do is use this vulnerability to steal user cookies. I could use it to redirect users. I'm sure we've seen things like maybe when we visit a website that's maybe a free website that we want to try to watch a movie and maybe download things. When you click on something, it redirects you to another site. So that redirect could be malicious. It could be just for ads. But if it's malicious, you wouldn't know. There may be scripts executing in your browser in the background, doing some other things that you may not know of. So just be careful when you're visiting links like that. And for account takeover, if I'm able to steal user cookies, then I can take over a user's account, log in as a user, change the person's password, and lock the person out. And also for data theft, yeah, you can steal personal data or financial information. So the next one is another injection attack. It's called SQL injection. So for this is quite critical because most web applications, or some web applications, talk to a database. When you're trying to log in with a username and password, it takes that credential, inserts it into a query, goes to database to query for if that user actually exists before it grants you access. And if that query is put in a code and not properly and the input is not properly sanitized, or that code is left unparameterized. So what parameterization means is, you are not taking an input from a user and inserting it directly into the code. You have to sieve it somewhere, clean it up before you now insert it into the code. That's what parameterization means. So you have to ensure that codes queries are parameterized. Also, your inputs are also sanitized, not just validated. You have to sanitize your inputs, ensure that any character, all these symbols are taken off before you insert it into your query. Because if this is not done, it can cause data exfiltration, it can cause data modification or denial of service. So an attacker can decide to play around with that query and get more details out of the database or even the application as a whole to understand the architecture of the application. And also can use it to, if it's successful, it can also use it to modify data in a database, by changing records in a database table, columns, and so on. Next one is authentication bypass. So I'll just speak briefly on this because of time. So authentication bypass is if the user is not able to, if the application is not validating who the person say he is, or then again, if the application allows the use of weak passwords, passwords are less than 6 digits, passwords are just words only and things like that, then this is another vulnerability that can occur. Also, if the website doesn't have two-factor authentication, this is another vulnerability that can occur because if credentials are leaked online, say for example, you are using same password across multiple sites. If one site is breached and leaked online, that password, an attacker can just use all of those details, create a word list, and try to brute force his way into another application using that same leaked details. So that's why you have to ensure you don't reuse passwords and on same passwords on several sites. And also you ensure your passwords are very strong. You could also use a password manager. Our phones these days, they have password managers. And also, if you don't have, you can always get one from the Google Play Store. Ensure it's reputable also because there are fake applications out there. Insecure direct object reference. This comes under weak access control, which I spoke about. It's just a sub-vulnerability under that category, weak access control, the first vulnerability on that list. So this, it involves user A being able to see user B's details. That's what this is about. Then the next one is denial of service. Sure, we must have heard about this. Denial of service is just when an attacker is able to send malicious traffic, large amounts of requests to a server. And if the server is not able to, if it's not built for that resiliency, I mean, you remember in the last class, the last session where they talked about QA, testing, stress testing a server, and all of those things. If that server is not built, did not undergo that process, and there is a DOS attack, it can render that server unavailable to legitimate users. Also, another way you can protect yourself against this is to employ something called a web application firewall. So this typically is on the layer 7 of the OSI model, where it protects your application against any form of denial of service attack. It could be a distributed one or from a single source. Next one is misconfiguration. I will just, so this is just about, I spoke about it. This is number 5 on the list as well, whereby you leave sensitive details in your code. It's not just sensitive details. If you're exposing sensitive details in your web application. Say, for example, you're trying to log in, you input a wrong password or a wrong username, and the application is telling you incorrect password instead of telling you invalid username or password. Then it's already giving you a hint that, oh, this password is wrong. Let me keep trying. So from there, you can build up a word list and try a brute force attack. So that's what misconfiguration speaks to. Then, yes, having learned about all the vulnerabilities and how it plagues web applications, how can you protect your web application? We need I'll speak from left to right. That's starting with secure coding practices. So this is essential. I don't know if we have heard about the term called DevSecOps. It was coined from DevOps with security embedded in it. So what it means is shift security to the left. There's another term called shift left. So you're taking security to the beginning of your development lifecycle. You're planning and building. You're planning and development phase or building phase, where you would employ a security measure called threat modeling, where it's just simply how you look around the application and see what possible threats or vulnerabilities that could occur on this type of application you are building. So different web applications have different types of vulnerabilities that could plague them. So you just manually or automatically look at the application and map out possible vulnerable points. Then moving on to the next cycle, which is your testing, you would employ things like static and dynamic assessments on your application to figure out things like misconfigurations, whether there are hard-coded secrets. You figure out all other misconfigurations, maybe HSTS missing, and several other misconfigurations. So it's essential that you scan your codes before you even release it during that testing phase. And sorry about that. You scan your codes and ensure that it's free of all these vulnerabilities like misconfiguration and all of that. So from after the testing phase, we usually have, depending on what your practice is, we usually have the release or the deployment stage. So this is where you would do more dynamic testing and ensure that applications and more penetration, and also employ penetration testing, manual testing, to ensure that your applications are resilient and free of vulnerabilities. And the cycle just goes on and on like that to ensure there is security everywhere. And also input validation is another one. I spoke of cross-site scripting and SQL injection. Ensure you validate your inputs before sending it to the server. Ensure you sanitize your inputs before sending it, validate and sanitize your inputs before sending it to a database as well, just to prevent some of these kind of attacks, cross-site scripting or SQL injection. There are several other types of injection attacks, PAT injection, XSEs, a lot of them out there. And finally, secure authentication. Ensure that your web application has multi-factor authentication, two-factor authentication, so that even if a user uses a weak password and an attacker is able to get past that first stage, imputing the username and password or brute forcing his way in, there will be something to stop him, which is a second factor. What do you have? Yes, you know your username and password, but what do you have before I can grant you access into this application? So if you don't have the biometrics, if you don't have your OTP, if you don't have your authenticator app, OTP from your authenticator app or things like that, then the attacker will be thwarted. He can't get into the application. So moving on is the Wi-Fi networks, a deep dive. So my colleague Gerald would take over from here.
Okay. Thank you very much again. Great work. Just 1 minute. Okay, confirm you can hear and see me.
I can hear you, but I can't see you.
I can hear, but I can't see you.
Okay, 1 minute. it good now?
Yes.
Yeah.
Okay, great. So thank you very much, Ekene. I'll just run off from where Ekene has stopped. Very, very good introduction into web applications, right? I want us to also realize that the purpose of this KSS is to marry vulnerabilities on applications generally to network, especially wireless network vulnerabilities. So we're not treating them in isolation. We want to marry them. So now he's talked about vulnerabilities on applications. What is the risk when you take the vulnerabilities on applications and you augment it with a vulnerable wireless network, right? And that brings us to the second part of this KSS. Wireless networks have become indispensable part of our lives, like Ekene had mentioned, right? We connect them, be it at home, at work, in the airport, wherever we are. The ease to always connect to a wireless network is easier, right? Compared to having to use a wired network. So the world really has evolved, and we all do a lot of things wirelessly, right? Which of course exposes us to a lot of risks. So what is the process of authenticating or connecting to an access point, to a wireless network? For us to understand the vulnerabilities that we're exposed to, we need to have a concept, a good understanding of how this connection works, right? So first of all, you pick up your client. So client in this instance would be your laptop, your mobile phones, your pads, whatever it is that you can use to connect to the internet, right? You pick it up and you scan your environment to identify available access points to connect to. After that, you authenticate, right? So you're authenticating with a PSK, that's the pre-shared key, right? Which is the password. So if you're authorized to connect that access point, you have the password already. So you authenticate to the access point, right? Then you have IP assignment, right? So if you think of IP as what let's say, right? So there's IP, right? Okay, you know what? I'll come back to that. So there's IP assignment, right? Upon successful authentication, the router assigns an IP to your client, to your device, and that's what you use to, that's what you use when you're connected to the access point. Then your internet access. After connecting, you access the internet with the IP that has been provided, right? So now, what are components of a Wi-Fi network? Right? We have router, we have access point, client, and I've mentioned clients being the device that you are using. Your internet service provider, we know the common guys in Nigeria now, that's the Glo. Glo is very fast. Airtel, MTN, Etisalat, it used to be Etisalat, now 9Mobile. So these are our ISPs. Then you have your router, right? And so I spoke about IP address and MAC address. So I'm trying to just be fast so that we don't spend so much time on these slides. Think of, when you say IP address and MAC address, think of a DHCP, right, which issues the IP address to your device once you connect as a hotel front desk person. And think of app, your MAC address rather as your ID card, right? So when you arrive at a hotel, you go to the front desk to request a room, right? Which in this point is the IP address. And now the front desk person assigns, you a specific room number, IP, that will be available from a period, right? So say you're booking for 2 days, you're booking for 1 night, whatever it is. So that room, in this instance, the IP address would be available for you and tells you how long you can stay. That's the least time. This ensures that everyone gets a room without confusion. So everyone knows their room. Nobody's going into another room. You know your room. And I can say, okay, Gerald is in this room. Ekene is in this room, right? So that's pretty much what IP address is and how DHCP assigns the IP address. The MAC address is the media access control address unique to the devices as the clients. Now, the difference between IP address and MAC address is the fact that IP address has a lease time, except in situations where it's been configured to be a static IP address on the network, most times it changes. So if I connect to a network today and I get a 192.168.0.0.2 and I connect next week, I might not get the same .0.2. It would very likely change because the lease time for the previous IP, or in this instance, a room, would have expired, right? And someone else would take over that, and I'll be given a separate IP address. Whereas the MAC address is typically always static; it doesn't change for the device that you're connecting with. So DHCP, pretty much, I'm just going to dive a little bit deeper, right? With this slide, we are wasting time. The process of getting IP from the DHCP. So once you connect, you can see the diagram on your right. That's like a router, right? And you have multiple devices trying to make a DHCP request to the DHCP, right? So the DHCP then gives, offers an IP address. Your device receives it and sends an acknowledgement to say, yes, thank you very much. I've accepted this IP address and I would be connecting to the internet with this IP address. So that's pretty much the process of the DHCP assigning an IP address. Also, very importantly, routing table. So I like to describe this like a Google map or Google Assistant, right? Not just a map, but an assistant. So what it does is it tries to help you determine, or try to help the traffic determine the fastest route to get to its destination and back to the source, right? So components of routing table, you will have the destination network, the next hop, and the interface. So without confusing you too much, just think of it like your Google map. You're going to walk, right? If I'm going to walk now, Google Map pretty much will tell me there are 3 roads I could pass: Milan Bridge, Echo Bridge, and whatnot. But it's going to tell me this is the fastest route. If you take this one, there's traffic here, you're going to, meet 30 minutes, 20 minutes delay, whatnot. So it tells me this is the fastest route to take this route. That's what the routing table pretty much does to your traffic. So it determines the fastest route for your traffic to get to its destination and get back to the source. So we now come to app spoofing, app in general. So these concepts are really important because they're going to play significant roles in the demo that we're going to have at the end of this slide. So before I speak about what app spoofing is, let me try and give a concept to what app is, right? So, I said DHCP was like the front desk person in a hotel. Now, just imagine app book. Once you are in the hotel, right, you need to deliver a message to another guest, but you only know their room number, IP. So you check the hotel directory app in this instance, and the directory helps you to match the room number, which is the IP, with the guest's name. So it's like a directory. It's like, in this case, it's going to be the hotel directory. You want to reach out, you want to send a message to another guest, but you can't send a message to the room. You need to know who the person you're sending the message to is, right? So how do you determine room number? How do you match room number to guest? That's what app does. It's like a directory. So it matches the IP address to the MAC address. In this instance, for our analogy, it matches the guest room, the room number, and it matches the room number to the guest that's in the room. So that's just a pretty much explanation of what app is. But what is app spoofing? So now imagine you have that you have that directory, and I'm staying in room number 1. My colleague Ekene is staying in room number 2, and there's a package, $1 million. Somebody's sending it to the hotel in cash for me in room number 1. And Ekene goes and changes the directory and says, hello guys, my name is Ekene Ejike, and I'm the one in room number 1, right? So whoever is delivering the gift will see, oh, room number 1, the guest is Ekene Ejike and not Gerald. And they deliver my $1 million. Ekene, I'll fight you, by the way. But they deliver my $1 million, right, to Ekene instead of bringing it to me. So that's app spoofing. A common attack technique where attackers send forged app packets to the network, misleading devices, right, about the MAC address. So in this instance, I use room number and name, but in actual world is saying, oh, my IP is 0.1, sorry, 0.2. Ekene's IP is 0.3, and I'm coming out to say, oh, hi, or rather Ekene is coming out to say, hi, his .0.3 is actually my MAC address, which means any data that's meant to be coming to my MAC address will be going to Ekene's device. So that's pretty much what app spoofing is. It exploits the trust between two devices on a network. The consequence of this is can be severe, right? Including denial of service. So the denial of service is Ekene is preventing me from getting my $1 million cash, right? Man-in-the-middle attacks, data theft. The attacks can intercept sensitive information. I'm sure Ekene had already mentioned some sensitive information when he was talking about some of the exploits for applications, right? Inject malicious codes or disrupt the network communication generally, causing significant damage and potential security breaches. So we've spoken about these the risk, these vulnerabilities, these exposures on wireless network, but how can they be exploited? Now, just like anything in life, generally, there must be a weakness. There must be an opening before something can get in, and that's where we come to the vulnerabilities on the network, right? So in this instance, with passwords or open access points, that's no password at all. So you just have your router or your Wi-Fi at home, or you even turn on your hotspot on your phone and you don't put a password. That's open access point. So pretty much you're just giving anybody access to your to your access points without even trying, right? Weak password, using passwords like 12345, ABCD, QWERTY, or password, right? So weak passwords are easily guessed or easily cracked. At the end of the day, would also still get an attacker or even an evil friend, who is just trying to get onto your network to bypass the weak password that you put. Outdated firmware. So, I'll use this analogy. Lots of us would probably have MiFis that we bought maybe 4 years ago, 5 years ago. And, you've just been using it. You haven't gotten a new one. I'm sure the MiFi, the battery has swollen, is begging you, please change me. But, you're still, using out the life, getting your money's values worth from it. So, but the problem is most people don't ever get to go to see, the updates on the firmware for this router or this MiFi. So maybe the service provider you bought it from has, made an update. It's just like your phone, we always get updates on our phone for the OS, but nobody cares to actually check the updates on these devices, which leaves them, exposed. Maybe the update that has been released fixes a particular vulnerability that has been identified, right? But you leave it that way, and you're exposing yourself. Then there's rogue access points. So, for instance, my Wi-Fi is Gerald. I come home one evening, I'm tired. I'm just trying to, get on my laptop to do stuff, and I see, Wi-Fi pop up and showing Gerald and asking me to put my password in again. And I'm wondering, why is my own Wi-Fi getting me to put my password again? And I just ignore and I just go ahead and punch my password in. What would have probably happened there is a malicious person, a threat actor would have said, okay, there's a Gerald somewhere in this vicinity, right? Let me put up a rogue access point with the name Gerald and see if this person is going to punch in his legit password. Once I do that, what I've done is I've given my actual password to my actual Gerald Wi-Fi, right, to this threat actor. So these vulnerabilities, at the end of the day, the goal, the aim, right, for the threat actors is to get onto your Wi-Fi network. Exploiting any of these vulnerabilities I have listed here is with the purpose of getting onto your access point. That's the main purpose of the threat actor. So other things would be Wi-Fi misconfigurations, disabled firewall. I am very sure maybe 90%, I'll set my money on it, 90% of us right here on this call, right, do not have Wi-Fi configured on our Wi-Fi, on our MiFi routers, whatever it is at home, right? So disabled firewalls, weak encryption using WEP, which we all know in the industry is weak, right, compared to WA2 and even a stronger encryption algorithm like WPA3, right? Then excessive broadcast, missing updates. So one other thing, something we could always do is limit the number of devices that can connect to our access point at every point in time. What that does is even if someone cracks your password, if you have just your phone and your laptop and you restrict the number of devices that can connect to your network to two, you will always at every given point in time have just two. So even if the person gets your password, he can't connect to the network because the limit you've set is just two. So for us to now understand how to marry vulnerabilities on web applications and network, it poses the question, how does my device, how does my device actually interact with a web application when I connect to a network, when I connect to a wireless network? What really happens? You just pick up your laptop and you go, www.facebook.com, www.linkedin.com, or whatever the web app is that you're reaching, and it just loads and pops. So what really goes on behind the scene? How do you reach the application? So the process is your device connects to a network, right? That's the access point. It transmits the data to the network, right? So once it transmits it to the network now goes ahead to forward your request to the application itself, right? And a typical application will have, a structure which will be the UI, which you would see on your client that has connected to the wireless access point. Then you will have a web server, and you will have an application server at the back. So the network forwards the request, sends the request rather to the web server. Web server receives it and sends it to the application server. Now, at the application server level, this is where the interaction goes on. So if it's an application that requires authentication, right, the database is going to check the credentials used for authenticating, are they valid? If they are valid, all right, it goes ahead to issue you authorization in form of an authorization token, right? So depending on how the application is configured, you might use an authorization token, let's say a JWT token. You might just use an access token. Some might just use session tokens. I have worked on applications that were so poorly configured, right? And they only use session tokens, and it was a financial application for a bank in this country. It was only using just session tokens as its means of authorization. Very bad, right? So the application server issues authorization, and that authorization token, whatever it has been designed to be, would now be used to retrieve data, right? So access and retrieve data resources that are meant for you as the user. It fetches it and sends it back. How does it get back to the user, right? So the application server generates the response, it sends it to the web server sends the response back to your network. That's the original network they use to connect to the web application, and your network sends the response to your access point, and the access point transmits it back to you, which is your device, your client. Now, it might be multiple devices, connecting to the access point at a given time and making requests. So the access point pretty much uses IP, then again, right, IP, to now provide response to all the devices or clients connected to it at the same time. So vulnerable access points, like I've said, so weak passwords, outdated firmware, and misconfigurations. These are the things that would allow an attacker, carry out this attack successfully and eventually perform what we call man-in-the-middle attack. So imagine this whole process I've explained to you, how to reach a web application, right? But now imagine somebody, an attacker or an evil friend connected to your network, sitting in between that's your device, and your network, that's your access point, right? So whenever you send a request, it's the man in the middle sees your request, can either manipulate it or just inspect it, forward it to the web application you're trying to reach, and the response is coming back. He sees the response, inspects it or manipulates it, and sends it back to you. So the risk here is imagine it's a financial transaction or financial application you're trying to perform. So the man in the middle could change, things like account number, it could even see your credentials. You imagine if the application happens to be a poorly configured application, it would see your login credentials or your session tokens. So pretty much that's the risk of having a man in the middle. And for you to have a man in the middle, you must have exploited one of these vulnerabilities rather on your access point, right? So what are the security measures that we can put in place? First of all, strong passwords, right? So I would always tell people this: every password is crackable, just so you know. So whatever password you think you have right now, be it a very long sentence, it's very, very much crackable. But the difference here is the time taken to crack the password. So there are passwords that I can crack in 10 seconds, the passwords that will require me, maybe 10 years or 100 or even my lifetime to crack it, right? But at the end of the day, it's actually crackable. Only you've got to keep me for that number of years, right? So use strong passwords and stay away from, dictionary words or short phrases. One of the passwords I've cracked in the past was somebody used, ethically, by the way, somebody used a very short phrase in the Bible. So Bible phrase, right? Jesus wept. And, you'll be thinking back, how would somebody crack, Jesus slept, or I love my mom, or it is my turn, all those really simple passwords. And I was able to crack them. So avoid using simple phrases or sentences that make sense. Rather use complex words, rather complex characters. So a mix of uppercase, lowercase, special characters, and numbers, right? And just have a good mix, right? Makes it more complex, makes it harder for it to be cracked. Then, of course, implements HTTPS. Now, this is on the application layer. Implement HTTPS on your application. So you will see the difference between, or you see the risk behind HTTP traffic when we get onto the demo session, right? Having HTTPS would more so provide, not complete, but provides a level of cover for your traffic, right? For your data in transit for when you're connecting on a network. I do have this, back and forth with developers who say, oh, why are you asking me to encrypt further when I'm already using HTTPS, right? So it's really never a one-stop solution to security for web apps, because although this is not something we're going to cover because of time on this call, there are extensive hacking techniques that can actually allow us to view your so-called HTTPS traffic in plain text, right? So if you have your data, not encrypted, but you claim your application is in HTTPS, I can still potentially, if I get on your network, I could still see your data in plain text, right? So then again, firewall to block unauthorized users, and regular updates to both your Wi-Fi devices and your applications as well. So moving on to case study, right? The impact of weak security on a wireless network and a web application. So the idea of this case is, like I said, I hinted earlier, is to marry web application vulnerabilities and Wi-Fi vulnerabilities. So we are going to consider a user who connects to a poorly configured or poorly protected wireless network, right? And then goes ahead to connect to another vulnerable web application. So first of all, that's, connects to a vulnerable access point, then connects to a vulnerable application. So what's the user exposed to? How can the weaknesses on both the application and wireless network layer be jointly exploited by a malicious threat actor or an evil friend? I always say these evil friends because there are plenty. You have somebody who is on your network, or you just share your password. Oh, how far? Please connect to my. Please, can I connect to your network? Those people. An attacker can be one of those people who just connects to your network and is doing something malicious on your network. So what happens is the application is vulnerable, all right, with security flaws, and it could allow the application to be exploited through most of the vulnerabilities my colleague Efene has spoken about. That's cross-site scripting, SQL injection, broken authentication, and a host of other attacks, right? Exploiting vulnerabilities. Then network access. If the user now goes ahead to access an application access the same application that's vulnerable over an unsecured Wi-Fi network, of course, an attacker will not be able to intercept the network traffic, steal sensitive data. We've already mentioned what sensitive data can be, and use that if it's credentials, use it to log onto the application, which pretty much gives me, because it's difficult to exploit an application if you can't get into the application. But if I sit on your network and I get your credentials, I now have access. I have the keys to the kingdom, right? So I can get into your application and I can now perform more attacks, secondary level attacks on your application, and do a lot of damage. Then data breach. So take this away from your personal case, right, and bring it maybe to your organization. Right? If your bank happens to have an application that's vulnerable, if this was the bank's application, right, that was compromised this way, it can lead to compromised data, which in turn would lead to, identity theft, financial fraud, reputational damage for the bank, right? So this gives you an idea of what can be the consequence if this scenario plays out in your organization. So we are taking away from, personnel at home and all the rest and bringing it to your organization. If your organization has poor wireless network configuration, so let's say your core banking or sensitive applications can be accessed via your wireless network in your, in your organization, and and those applications are also vulnerable, right? Maybe to loads of attacks or loads of vulnerabilities, and then in turn you have weak security policies on your Wi-Fi, Wi-Fi network. So if this plays out in your organization, you are sitting duck for for a potential compromise in your organization. So away from that, some of the tools we'll be working with today would be, Kali, with a host of other tools on Kali like Aircrack NG, BetterCap for network sniffing. Yeah, you see a lot of them, right? And without further, delay in your time, let's hack something together, right? So this brings us to the demo part of this KSS. Boss, I hope I haven't spent too much time. Mr. Tony.
You're doing great. A bit of a disclaimer, right? A bit of a disclaimer. This is to be done ethically, right? The whole essence behind this session is such that as tech risk practitioners, we're able to test out these weaknesses in our organizations for fixing. So not just in our organizations, but also in our own personal space. And some of the things that the speakers have alluded to, I'm sure for some of us, we can relate with them. Some may be pretty new, but again, there's some learning, right? So you're doing well on time. Go ahead, please.
Thank you. Thank you very much, Mogatuni. I was definitely going to...
We need time for questions, right? So we have just 35 minutes to go. We'll need to try and see how we wrap up so we can have a session for questions.
Right? No problem at all.
Then if you have a question, maybe you want to drop them on the chat, it could be answered, or want to wait till the end. But if you can drop them on the chat because of time, please go ahead, Gerald.
Okay, thank you very much. I was going to mention that please don't go around, hacking people's Wi-Fi. It's not ethical. Everything we're doing here is just for educational purposes to, improve security. So I'll go ahead and share my screen in a minute. Okay, please confirm you can see my screen.
Yes, I can.
Okay, so I'll be working, the first tool I'll be using will be M1NG, right? So first of all, when I get here, what we want to do, like we said, what's the process to connect to a network? We want to scan your environment to identify potential access points that you can, connect to. So first of all, I'd like to say that one other tool or a device I'm using for this is a wireless interface, right? So because the interface you have built in your system can't perform this kind of attack. Reason being, if you see what I've highlighted here, the mode for your interface is going to be managed just like what I have here, but you need to be able to change this mode to monitor mode. Monitor mode is what's going to allow you to be able to allow your tool to discover access points and then perform the hack on them. So my interface is currently on monitor mode. I'm going to put it on, sorry, it's on manage mode, apologies. I'm going to put it on monitor mode right now. on check kill. If any process is currently running. All right, so this process was running and I have to kill this process first before I start. All right, so you can see this is my physical drive, my physical device rather, right? And I have successfully placed it on monitor mode. Next, I want to just confirm this and say I config, and this is it here. It's changed to monitor mode, so we're good to go. After this, next thing I want to do is now I want to identify networks around. So first, I'm going to be hacking my own network, right? So I need to find it. Error dump. And the interface that I'm going to be running on. All right, so great. I just wanted to capture a bunch of other networks. I'm going to close this now. And this is right. This is the network of access point of interest. So you have Gerald. So you can see there are other other devices, sorry, other access points that have been identified. But like this is the access point of interest. So the next command I'm going to do is I want to start monitoring or listening on this particular network, right? So I'm going to run a different command, which is error dump. So yeah, this BSS ID, you can see it's already all I need to do is just, okay, I've done this already. I just had to check earlier today to make sure this was going to be good. So the BSS ID is the SSID for my network, which is this. All right, so as you can see, 98 and ends with 58. The channel, my access point is currently on channel 11, and I'm creating a file. So I need a particular file because I'm trying to capture a WPA handshake, right? And it's going to be saved into a particular file. So I need to give the name of the file. I've already had one, so I'm just going to call this class hack 2, right? And the interface I'm working with is same, WLAN 0. So now I'm listening on this particular on my own network, right? So I have about 5 devices or 4, my TV, my two of my laptops, my phone, my tab, right? So these are the devices that are connected. I know the MAC address for my phone is this 42, it's the second one pretty much. So that I don't interrupt this class, I'm going to try to deauthenticate my phone. So the idea of this is you force a device that's already connected to the network to deauthenticate from the network and try to connect back because that device already has the password, right? So you're going to capture what we call the WPA handshake. And that's what we're going to crack to get the password. So I wouldn't be sending this to the whole network. If not, I'll just throw myself out of this call. So I'll just disconnect just my phone using this command airplay ng deauth. And I'm just going to send 5 requests. So now this number is, if you're having situations where you're not capturing the WPA handshake, you can increase this number as you deem fit. What this pretty much does is it sends as much as the number is, it sends that the count of the authentication requests. So I'm just going to leave it at 5, and my MAC address is 4205. Let me just get that from here. Okay, so 4. Okay. Right, this is what I wanted, so I don't have to force myself to type it. Let's change this to 5. So this is the IP, this is the MAC address for my network, and this is the MAC address for my phone, and that's the interface WLAN. So it's sending the DAuth request now, and we'll go back here to check. Aha, voila, see, WPA handshake has been captured on my network. So I could just, okay, this is ended. I could come and close this one. I have what I need rather. Then I use a different tool, which will be aircrack ng. So aircrack ng is going to go ahead to crack the password that I have captured. Right. So that I could save time. This command here is just identifying the word list that I'll be using for this hack, while this one here is the directory where the file I have captured is saved. So you see, we are currently in home Kali Wi-Fi hacks, and the file is going to be right. So yeah, class 01 was the first one I just did this morning just to confirm. So we're working with class hack 2, right? So I'm just gonna say 2. Yeah, .cap, that's the file that I need, right? So and I'm gonna hit enter. So I'm cracking the password. If it's a simple password, it will take not so long. If it's a more complex password, it will take a lot of time, right? So you can see the number of keys it's going to be checking against before it cracks this password. So let's see how long it's going to take to crack my password, and let's eventually find out what password I used for my router. All right, key found. Wow. So my password was password 123. If I take this right now and I if I try to connect with it, you will see that I can connect successfully to this network with password 123. So what I'm going to do now, I'm going to disconnect this. And connect it to So we've actually literally just performed the first part of this attack, right? Which is to determine, that's the Wi-Fi hack. So what the risk here, right, or the vulnerability that was exploited here was weak password configuration, right? So I used a very, very simple password. And as you can see, it took me just 32 seconds, right, to crack my own password. And I'm going to try to connect to this network now with my other machine just to show that the password is valid. Just give me 1 second to restore my virtual machine. Great. All right.
Yeah.
Okay, so I am going to try to connect to this Wi-Fi now. Great.
Oh, you,
so that I don't waste time. My wireless network is not coming up on my Windows, but then that's pretty much the password for the Wi-Fi. I don't want to have to waste our time, so that we take questions. So this brings us to the next stage of our attack. We've already done the Wi-Fi password capture. So we're just going to assume now that we are connected to the same network as the victim, right? Where the attacker will be connected to the same network as the victim. What's the next thing that would happen? I'm just going to sit on your network. I'm going to wait for you to connect to a vulnerable application and sniff your sensitive information, right? So what I'm going to do next is connect to a vulnerable application. We've picked out a particular application which is deliberately vulnerable. Unfortunately, we couldn't, although there are options of actual production applications out there that we've already tested, we've sent reports to the organizations for them to fix, but we can't. This is being recorded. I'm sure this is probably streaming live on on LinkedIn, right? So we can't go around hacking people's application, production application while stuff is streaming. So maybe in a more different class, Mr. Stoney, we might be able to showcase something a bit more on production. But we're going to be sticking to applications on that have been created deliberately to be vulnerable, right? Just give me a minute to restart my Kali. Mind you, I also mentioned that it's difficult getting one single application that's deliberately vulnerable to multiple vulnerabilities. Most of them out there have been created to be vulnerable to maybe just one or two vulnerabilities. So we'll be working with if time permits, we'll probably work with two applications. I'm just going to show you one, how the credentials can possibly be captured, right? Then my colleague Ekene is going to show you how maybe another application can be exploited in more detail, or if time will not permit, we'll stick to just this one application. All right, Kali is coming back up. Then again, for people who are wondering, Kali, what's Kali? I think Mr. Tony is, probably going to put something together, that would like a class or something that would, work more on, understanding Kali, introduction to Kali Linux tools, how to set up, your VMware, how to set up, a virtual laptop and the rest. Maybe in a different class, not this one because of time. So we'll just go straight to what we have here. Okay, so now the tool we're going to be using is called BetterCap. Works very similar to what we know as what we call Wireshark. But for this particular tool, the reason why I prefer it to Wireshark is I do some things that we're not going to discuss today on this call, right? But yeah, we're going to be using BetterCap. So, sorry, beg your pardon. Okay. All right. Don't get confused with all these commands. They're just commands that you could you could really get if you're not conversant with Kali. So what I'm doing is I'm starting up my BetterCap application, my BetterCap tool, and I'm identifying the interface that I want to listen on, which is ETH0, right? That's the interface that I'm currently connected to. Right, so I want to listen on this interface because that's where all my devices are connected to. So once it starts up, I will begin to listen to capture anything I see on Okay, waiting for this to come up. Sorry, I forgot. I didn't know I was muted. So to save time, the problem with this, these tools, they consume a lot of resource, and my system, my VMware happens to be hanging. So the idea of this step I'm trying to perform is to capture the password to log on to a vulnerable web application, right? So this is the same application my colleague is going to work with. What I just wanted to, showcase to you here was how I would listen on the network. I would, use my Windows machine here to connect to the same application and capture the password, right? Which at the end of the day, I would now, in turn give to my colleague who would now use it to log on to this application to perform a more robust application security pen test or attack on the application. So just to save time, if this works before, we finish up the class, we'll come back to this. But for now, let me allow Ekene come back and, display the application security part. But before I do that, I'm just going to show you a sample of what it looks like when you capture, the credentials in plain text, right? So allow me just show you this. So just confirm, let me know when you can see my screen. Can anyone see my screen?
I'm still seeing your card.
Okay, 1 minute, please. Sorry. I'm just trying to show you an example of what captured. Okay. How about now?
Yeah.
Yes. Yes.
Aha.
Yeah.
God bless you. So this is the request to a particular web application, right? It's vulnerable because it uses HTTP instead of HTTPS, right? Remember, we said the S stands for secure. It makes everything you're passing on the network to be encrypted. But this application, apparently, it's a banking app, by the way, and it uses HTTP. So you can see this is the login request from the user, which was me, right? You can see user login, the username is username, and user password is password. So if I'm sitting on the network, I would easily capture, username and password alongside session token. That's the user token, right? And I would also even be able to get more information, which would be the token, right? So the token, see the response. So this was the request, and this is the response that came back from the application server. Remember, we said interaction with the application, you would send a request, and the web server is going to generate a response and send back to you. So this will be the response. And this is the user token that the user is going to probably need to authorize to make transactions. Now, this is different from your PIN. This token allows you to call the resources on the application, right? So you can't load the web page for the application without having a valid token. So if I'm capturing something like this, I have the user's credentials, I have the session token, and I can use it, or I can give it to someone, like Ekene, right, who would now go ahead to perform a more sophisticated attack on these applications. Apologies, unfortunately, my colleague just frozen on me. But yeah, this is the idea: be able to capture this traffic to see this information. Hopefully, if we have another time, another session sometime, we can go into detail, not just limited to HTTP, like I said, right? Because there are also ways to see HTTPS traffic in plain, just like this, right? But that's not something we're going to be touching on today. It's going to be for a different session. So I'll allow Ekene to carry on now with the web application hacking demo of this session. Thank you very much.
All right, thanks, Gerald. We are running out of time. Can we do this in 5 minutes? I doubt. Maybe just let's just test for one vulnerability, right? I know
All right,
a lot of questions have been dropped and there have been attempts to answer them, except we're hoping that there will be no other questions at the end of the session, but we just have about 10 minutes to go. So please go ahead.
All right. Thank you very much, Gerald. Hello again. So I'll just be demonstrating some of the attacks. Let's just assume maybe one or two. Let's just assume Gerald has gotten the credentials. Apologies for that blip. And he passed them on to me. So here is the application, zerowebapplication.security.com. And he has passed the username and password to me. I'll just go ahead and impute username and password. Can someone confirm that you can see my screen, please?
Yes, I can proceed.
All right, so before I hit enter, I'll just put my mouse here and show you one security misconfiguration. So if you see here, it says login/password is username/password. So this is already giving away the password. And this may not be a finding that you would see often, but I just want to show you what misconfigurations look like. And I would hit enter, to sign in. I have my Bob suite open behind. It's just a proxy tool that captures requests and responses from an application. So it typically operates at the application layer. And what I would do is I would just show a cross-site scripting vulnerability and also another misconfiguration. So if I go to, I just do, this is another misconfiguration, first of all. This is the web application. I just do /admin. Sorry, I'm going a bit too fast, but we're running out of time. So it says this is not found. Okay, let me do it this way. All right, just copy and paste this here. All right, so we have the admin console now, and we can see home, users, currency, and all of this. So there's a cross-site scripting vulnerability here. Yeah, I know that because I've worked on this application previously. It's a vulnerable application, so I have kind of like tested and know where the vulnerable points. So you have to, first of all, during pen testing, reconnaissance is key. You need to touch all the application endpoints before you start to and touch all the application endpoints, look for vulnerabilities before you start exploiting. So here I'll click on add currency. This particular point is vulnerable to cross-site scripting. And you see when I click, a new request gets added here by the left side. I'll just add a random, let's say 09. Country. So now this is the cross-site scripting vulnerability I want to use. It's called it's a reflected cross-site scripting vulnerability. Sorry, I'm just trying to grab the payload because it's just for accuracy rather than typing. This is it. Yeah. So what this does is unload. So whenever you are reloading your page, alert 1 for me. That's what this injection attack does. So it will be stored in this page. So whenever you reload it, it's both a stored and reflected. Whenever you reload the page, alert 1 for me. So there are other ways to exploit this further. You can exploit this remotely, but because of time, I will not be able to show that. I just click on add. Clicking on add now, you can see it has added successfully. Now I'll click on currencies again, and it pops up. It's alert 1 for me. Do okay, 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 okay. So now you can see it gets added here, but nothing. If I do add again, I'll just modify it quickly. 7, do this rather than alert 1. I'll just alert, okay, let me just put KSS session. Put it here again. So this is what you can do with it. Currencies. Oh no, I mistakenly pasted. Sorry, so you get the idea though. In that bracket, you can put whatever you need to alert. But when you're exploiting this, you're not alerting to the user because you don't want the user to know that, oh, there's an actual vulnerability here, or why is it popping up like this? So you'd have to change that alert to something else. Maybe you're trying to get the cookies, you replace it with something like document.cookie, and you can get the cookies and send it to wherever you want, not to the user though. You need to add like a command and control, like a CNC or a server where it will send all those cookies to. Now I just click on add currency again. There's another vulnerability here. This is called HTML injection. So it's just like how we have HTML pages where we add tags, href. Href is just used to add a URL, maybe for redirection or to display some more information that's not part of the current website. So I'll add it here again and click on add. So now if I click on currencies again, because that's our previous cross-site scripting is stored, it will keep on popping up because what I've done is on reload alert 1. That's what that one is doing. So now see the new injection attack here. Here is a new injection attack, a HTML page that I injected into this vulnerable web application. So now, if I click on this, it should redirect me to that website. Now you see what happens. Because it's trying to redirect me to this path on the server. Because it's not available, it's throwing a 404 error, not found. So now, here is also another vulnerability here that shows the web server this application is running on, Apache Tomcat 7.0.70. And now you can take this information because you might say, okay, what is it? I'll just go here on, let me just use a different browser, sorry. I'll just go to Google, paste this and type vulnerabilities. So this is how attackers work generally. When they find information, they will now check what can they do with this information. Why is this coming up? So all I'm trying to do is trying to check for the vulnerabilities associated with this specific web server. I don't know why this is coming up. Oh no. Quickly. God. I hate this. Okay. Let's just see. In the next 1 minute, I'll be rounding up. All right. So now I am searching for vulnerabilities related to this. If I click on here, there's still the CVE details as well. Sync is also another site you can use to check for vulnerabilities. And the thing about all of these software component related vulnerabilities or even server is that there are POCs available. So someone can just go online, grab it and replicate it. So you can see improper MPL validation. And these are the versions that this vulnerability can be found on. So you just have to do more research. That's just the way the whole hacking term is. So I think there will be no more time for demonstrating further vulnerabilities, but yeah, we can have like a separate class where we can go in detail using the OWASP top 10 from 1 to 10 and demonstrate all of these vulnerabilities.
All right. Thank you. Thank you, Gerald. Thank you, Ekene. And thank you to everyone that has made out time to join this session. I know we didn't really publicize this session, but in case you are not part of the community, the WhatsApp community, and you are interested in joining, I will just drop the link there for you to consider. The WhatsApp community has turned to a talent hub, and we are set up largely to support each other grow our careers. So if you're not part of it and you want to be, please join using the link. We have a page on LinkedIn, and then you would also find some of the other resources, other knowledge sharing sessions that we've had. You find it on our YouTube page, right? That said, thank you for all of us that have asked questions. Some of the answers we have dropped here. I'll try and see if we can collate these questions, match them up with the answers, and then again, just for posterity's sake, drop them on the group chat for others to learn from, right? Special thanks once again to our faculties. God bless you guys, right? And enjoy the rest of your weekend. Bye.
All right. Thank you, everyone, for joining.
Thank you. Thank you. Have a
Thank
lovely day.
you. I appreciate it.